Hello future engineers, welcome to my YouTube channel. Here is another video on beam deflections, and this is again to be solved by multiple methods, 8 methods in particular. So this is part 1.1, another problem by double integration method. So this is the problem. Uh, by double integration method, or DIM, determine the slope and deflection at points C and D. And there is also a problem for you to participate, that is the slope and deflection at F. So I want you to verify that the reactions at B and E are the following. So RB is 86.25 kilonewtons, sum up moment about E, and RD is 69.75 kilonewtons. So of course, that's your contribution or part because this is indeterminate beam, and it is expected of you that you can analyze the reactions. So these are the reactions. If you cannot solve it again. Solve the reactions again. So this is our sectioning. Up to this section here, we'll call the intensity of the loading here as W. So W as to x minus 7 equals 24 as to 3. So let's call that W. W as to x minus 7 equals 24 as to 3. Therefore, W in general in terms of x is 8 times quantity x minus 7. So the singular equation for the differential equation of the elastic curve is EI. Y double prime is quantity is 86.25 times quantity x minus 1, then plus 69.75 quantity x minus 9, then plus, imagine this load is extended up to here, so there's also an upward load of intensity 20 kilonewton per meter from C to between E and F. So plus 20 times x minus 5 times x minus 5 over 2, so that's why we have 10 times x minus 5 quantity square. Then because this is extended up to here, minus 10x square minus 20 times quantity x minus 7, then minus the moment of this triangular load, 1/2 of quantity x minus 7 times W, which is 8 times quantity x minus 7 times the moment arm x minus 7 over 3. Simplifying, EI y double prime is 86.25 times quantity x minus 1 plus 69.75 x minus 9 plus 10 quantity x minus 5 square minus 10x square minus 20x minus 7 minus 4 thirds x minus 7 cube. Integrating once, EIY prime equals 345 over 8 x minus 1 square plus 279 over 8 x minus 9 square plus 10 thirds x minus 5 cube minus 10 thirds x cube minus 10 x minus 7 square minus 1 third of quantity x minus 7 to the fourth plus c sub 1. Integrating again, EIY equals 115 over 8 quantity x minus 1 cube plus 93 over 8x minus 9 cube plus 5 over 6x minus 5 to the fourth minus 5 6x to the fourth minus 10 thirds x minus 7 cube minus x minus 7 to the fifth over 15 plus c sub 1x plus c sub 2. C sub 1 over EI is the slope at point A on the beam, and C sub 2 is the deflection at A. That's the meaning of that. Let's now apply the boundary condition, which is x is 1, y is 0, x is 9, y is also 0. So for x is 1, y is 0, 0 equals negative 5, 6, 1 to the fourth plus c sub 1 times 1 plus c sub 2. Simplifying, c sub 1 plus c sub 2 equals 5 over 6. So we will call that equation 1. Then next is when x is 9, y is 0. So EI 0 equals 115 times 8 cubed plus 5 over 6 times 4 to the fourth minus 5 over 6, 9 to the fourth minus 10 thirds 2 cubed minus 2 to the fifth over 15 plus c sub 1 times 9 plus c sub 2. Simplifying 9 c sub 1 plus c sub 2 equals negative 62,311 over 30. Solving equations 1 and 2 simultaneously, we get c sub 1 equals negative 3896 over 15 and c sub 2 7817 over 30. As I said, the meaning of this divided by EI, c sub 1 is divided by EI is the slope at A, while c sub 2 over EI is the deflection at A. We now compute the slope at C. X is 5. Substitute into this equation here. So EI theta C is 345 over 8. 4 square 0, 0 minus 10 thirds 5 cube, then plus C sub 1, which is negative 3896 over 15. So theta C can now be solved, found 13.6 over EI. When x is 5, we can solve delta C into this equation. 115 over 8, 4 cubed, minus 5 over 6, 5 to the fourth, then plus negative 3896 over 15 times 5, then plus C sub 2, which is 7817 over 30. So delta C, deflection at C is negative 638.933 over EI. Then when x is 7, we can compute theta d and delta d. So x is 7, substitute into this equation first. 345 EI theta d equals 345 over 8, 6 square plus 10 thirds 2 cube minus 10 thirds 7 cube, then minus c sub 1 or plus c sub 1, which is negative 3896 over 15. So theta d is equal to 176.1 over EI. X is 7. We can compute delta d into this equation. 115 over 8, 8 cube. X is 7. Plus 5 over 6, 2 to the fourth. Minus 5 over 6, 7 to the fourth. Then plus C sub 1, which is negative 3896 over 15 times 7 plus C sub 2, which is 7817 over 30. So delta D can now be found. It is equal to negative 6601 over 15 EI or negative 440.0637 over EI. Then for your part, I want you to find the slope and deflection at F and show that they are respectively 234.6 over EI for theta F and delta F 235.5 over EI. So that's it for this video.